Rogério. Gostaria de chamar para compor a mesa as organizadoras do Prêmio IC, Daiane Rossi, Isabela Boaventura e Ana Paula Condorf, representando a comissão do Prêmio de Tese e Dissertação 2022. Rogério, você quer também ficar na mesa? Então... Para falar do Prêmio IC, passo a palavra para a Daiane e Isabela.
Oi, gente, bom dia a todas e todos. A gente está aqui hoje, então, para divulgar o Prêmio de Melhor Trabalho de Iniciação Científica, que foram os pôsteres que vocês viram, ficaram expostos durante todo o evento. E, além desses pôsteres presenciais, a gente também teve os pôsteres virtuais, que estão disponíveis no nosso site do evento e também numa playlist no YouTube e no canal da SBHC. Então, antes de anunciar os premiados, a gente queria brevemente fazer um balanço do que foi esse momento, né, dos alunos, que é tão importante para a formação deles. Nós tivemos alunos tanto do ensino médio quanto da graduação também, né? Então, a gente teve no total 36 trabalhos inscritos. Destes foram 66 pessoas envolvidas, né, entre alunos, autores, coautores, orientadores. Alguns dados, né, porque quem me conhece sabe que eu tenho que levantar algumas estatísticas. Então, 61% do sexo feminino, 39% do sexo masculino, envolveu 10 estados, sendo que a maioria foi 9 trabalhos de São Paulo, seguido por 6 trabalhos do Amazonas, 5 do Rio de Janeiro, 4 do Rio Grande do Sul, Rio Grande do Norte, Goiás, Minas Gerais e Mato Grosso do Sul, 3 trabalhos, Bahia 2 e Pará 1. Nós tivemos como formação 13 áreas diferentes, predominando a física e a história, seguidos por biologia, arquitetura, química e medicina. Sobre a cor dos participantes, nós tivemos 59% se declarando branca, 33% parda, 3 negros e 5 não quiseram responder. Então, esse é o perfil dos alunos que se inscreveram no Prêmio de Iniciação Científica da SBHC.
A comissão avaliadora foi formada por Júlio César Pereira da Silva, da PPLeste USP, Mariana Salvador, da PPG HCS Fiocruz, Luiz Cambraia Cará Gouveia da Silva, Unesp USP, e Gabriel Quenço Rodrigues, da PPLeste USP.
E a gente agradece muito. E aí, agora, o grande momento, né, de Oscar Gomes. Vamos divulgar a primeira menção honrosa. Menção honrosa foi para o trabalho. A historicidade do benzeno, a construção de um artefato técnico-científico, de Ana Carolina Ribeiro Menezes, do Cefet, Minas Gerais, orientado pelo Braulio Silva Chaves. Esse foi um trabalho que foi divulgado virtualmente. A Ana Carolina e o Braulio não vieram, então a gente depois vai enviar para eles os certificados.
Agora vai. O prêmio Melhor Trabalho de Iniciação Científica vai para Loucura em Atas, as práticas e representações do Sanatório Antônio Paulo Cansado, de João Vitor Leal Lobato, da UFJ, e seu orientador, Éder Mendes de Paula, ambos da UFJ, Universidade Federal de Jataí.
O João Vitor ainda está aí, ele estava presente, mas, enfim, depois a gente envia para eles. Obrigada. Parabéns a todos.
Parabéns.
Vou passar a palavra para a Ana Paula Condorf.
Olá, pessoal. Bom dia a todos e a todas. Então, é com enorme alegria que realizamos a entrega dos prêmios de melhor dissertação e melhor tese em História das Ciências da edição de 2022. Antes, porém, de realizar a entrega dos prêmios e das menções honrosas atribuídas, gostaríamos de agradecer aos 24 pesquisadores e pesquisadoras que enviaram seus trabalhos para esta edição do prêmio. Foram 9 dissertações de mestrado e 15 teses de doutorado produzidas em 3 instituições localizadas em 7 estados do país. Gostaríamos de agradecer ainda aos colegas e às colegas que generosamente integraram a comissão avaliadora dos trabalhos, realizando uma difícil tarefa. Bom, agora vamos aos prêmios. O prêmio SBHC de melhor dissertação foi concedida a Matheus Camilo Coelho, com o trabalho Objetos entre Contextos e Significados, as coleções etnográficas do Museu Paraense Emílio Gold entre 1894 e 1905, defendido junto ao Programa de Pós-Graduação em História Social da Amazônia, Universidade Federal do Pará, e orientado por Nelson Rodrigues Sanjá.
Obrigado. Bom, primeiramente eu gostaria de agradecer ao evento pela SBHC pelo prêmio. Também agradecer, eu acho que é especial nesse momento que a gente vive, agradecer a CAPES pela bolsa de 2 anos que eu tive no mestrado, a Universidade Federal do Pará, que me ajudou em viagens, em eventos, ao programa de pós-graduação também. Fazer uma defesa também da universidade, eu acho que é um momento importante de se fazer. A gente vive num momento em que a ciência está sendo ameaçada, a democracia também está sendo ameaçada, então agradecer pela ciência e também fazer, durante o meu agradecimento, também agradecer as populações indígenas com as quais eu estudei, suas coleções, que do Pará estão passando por um momento muito complicado, muito difícil, de ameaça pelo garimpo. Então, também fazer uma menção a elas, meu agradecimento ao povo Memegocrê, em especial. Bom, também agradecer ao professor Nelson Sanjade pela orientação durante esses anos, com paciência, com muita atenção. Também agradecer aos meus pais, que não estão aqui, mas que irão estar felizes lá em Belém. E, bom, agradecer a minha família como um todo, aos meus colegas e amigos de História da Ciência na Amazônia, do grupo de pesquisa. E, bom, é isso. Muito obrigado a todos. Né?
Bom, a menção honrosa do Prêmio SBHC de melhor dissertação foi concedida a Gabriel Schunk Pereira, com o trabalho Ciência, Política e Biodiversidade, o livro vermelho das espécies ameaçadas de extinção da fauna de Minas Gerais, 1989 e 1998, defendida no programa de pós-graduação em História da Universidade Federal de Minas Gerais e orientado por Eli Bergo de Carvalho.
Bom dia. Eu gostaria muito de agradecer à sociedade pela oportunidade, pelo reconhecimento, parabenizar o Matheus por esse prêmio. Eu queria agradecer em especial ao meu orientador, que não pôde vir, ele está na Argentina, mas pediu para eu representá-lo, Agradecer ao Ciência, né, com a Rita, a Anne, né, e os outros professores e professoras que me ajudaram desde a iniciação científica, a FAPEMIG, né, que é um projeto que eu venho desenvolvendo desde a iniciação científica, que evoluiu com o mestrado, se Deus quiser, com o doutorado. Agradecer a CAPES pelos 2 anos de apoio, né, sem essa bolsa não teria sido possível. Agradecer a minha esposa, que também é presente, que me apoiou bastante no meio de uma pandemia. Não foi difícil, nesses 2 anos e meio de escrita, pesquisa, defesa, enfim. E agradecer a todos aqui presentes pelo reconhecimento. Muito obrigado. É isso.
O prêmio SBHC de melhor tese foi concedido a Breno Sabino Leite de Souza, por trabalho Etnografia, Arqueologia e Indigenismo no Museu Paulista, Índios, Colonização e a Construção do Brasil Meridional, de Hermann von Ehring, 1894-1916, defendido no programa de pós-graduação em História das Ciências e da Saúde, Casa de Oswaldo Cruz, Fiocruz, e orientado por Taori Kodan.
Bom, em nome do Breno, gostaria de agradecer, né, a SBHC, aos colegas que participaram do processo de formação do Breno, né? Eu acho que essa é uma questão muito importante, como é que a gente também está um pouquinho aqui, né, nesse resultado. Eu espero muito, na verdade, estou aqui falando para o Breno, né? Muita sorte daqui para frente com esse prêmio para ele, e que é uma vitória para a gente também. Agradecer ao programa, né, o nosso programa, agradecer muito a SBHC, e é isso, gente.
E, por fim, a menção honrosa do prêmio SBHC de melhor tese foi concedida a Crenivaldo Regis Veloso Júnior com o trabalho O Artesanato da Produção Acadêmica, Histórias, Coleções e Saberes na Trajetória, de Heloísa Fenelon, defendida junto ao programa de pós-graduação em História da Unirio e orientado por Heloísa Maria Bertoldi Domingues.
Bem, bom dia a todos e todas. Quero agradecer à comissão que, enfim, teve essa incumbência, né, de avaliar os trabalhos. Agradecer à presidência e à direção da sociedade, a todos que são associados, né, à SBHC. Agradecer ao programa de História da Unirio, em parceria com o MAST, e agradecer aos colegas do Museu Nacional, né. Eu acho que todos nós estamos passando por situações tão complexas nos últimos anos. Saudar também os colegas e as colegas que concluíram seus trabalhos nesse período. Todo mundo que escreve dissertação, escreve tese, sabe, todo mundo aqui sabe o que significa isso. E ainda mais num contexto pandêmico, e como o colega falou anteriormente, de ataque, né, às instituições, ao fazer científico, a ciência, a tecnologia, a arte, a cultura, de modo geral. E o Museu Nacional, vocês sabem, que passou, né, por esse trágico incêndio, então a situação, não dá para ficar comparando tragédias, mas não é fácil, não foi fácil para mim concluir esse trabalho. Então, agradecer a minha família, né, lá em Recife e em Salvador, agradecer a minha esposa e meu cachorrinho, que se chama Alecrim, uma fofura, e minha esposa também defendeu uma tese nesse mesmo período, né, então 2 teses dentro de casa, né, não foi algo fácil, mas conseguimos, vencemos. E eu quero saudar também a essa personagem sobre a qual eu fiz a tese, a Heloísa Fenelon, alguém que poderia ter ficado no esquecimento, né? Principalmente, acho que depois do incêndio, os arquivos foram totalmente atingidos, e eu acho que com essa tese a gente ajuda aí a trazer luz sobre personagens que, de outro modo, ficariam no campo do esquecimento. Então, muito obrigado a todos.
Bom, em nome da comissão organizadora, então, dessa edição do Prêmio e da SBHC, eu agradeço mais uma vez a participação de todas e todos e parabenizo os autores dos trabalhos destacados. Muito obrigada.
Gostaria de chamar os premiados que estão aqui, seus orientadores, a Aninha, Rita, representando a UFMG e o Ciência, para a gente tirar uma foto com a SBHC e conosco, né? Para a posteridade.
Começou para cá.
Pode? Cadê os meninos? Não vieram? Eu não sabia como que era. Não tinha ninguém. Nenhum.
Olha para mim, por favor. Já está mais?
Olhar por nós. Manda pelo zap.
Vai trazer mais.
Você sabe se o grupo já está lá ou não?
Melhor você... Alguém começar a assumir agora.
Eu vou apresentar.
Agora vamos começar, vamos ver se a palestrante que vai fazer já a conferência de encerramento já está online e vou passar a direção da mesa para o Rogério, que vai coordenar os trabalhos.
Ela já está lá. Ok. Ruth, do you listen us?
Yes, yes.
Ok. Bom, então, é um prazer, na verdade, a gente estar aqui, chegar quase ao final, falta muito pouquinho para terminar. Então, agora a gente vai fazer a última conferência do seminário. Mais à tarde, a gente tem a assembleia da associação, a partir das 14h. Então, está todo mundo convidado para esses finalmente, né, do seminário. A professora Ruth Mostern é professora associada no Departamento de História da Universidade de Pittsburgh. Recentemente foi promovida a professora titular, né, do mesmo departamento. Desde o seu doutorado de 2003 pela Universidade da Califórnia, Berkeley, ela tem estudado a história da China, desenvolvendo análise de longa duração sobre questões ambientais, a ocupação do espaço, as relações entre humanos e a paisagem. Dr. Mostern publicou 2 importantes livros sobre o tema: Dividing the Realm in Order to Govern, The Spatial Organization on the Sound State, nas séries monográficas da Harvard Yenching Institute, em 2011. Ano passado, ela publicou pela Yale University Press o livro Use Trace, The Ecological and Imperial Birds of the Yellow River. Dr. Mostern tem feito importantes contribuições para o uso das tecnologias digitais no trato da história ambiental, 2 temas em ascensão na historiografia das ciências do Brasil. E hoje ela fecha o nosso seminário com a conferência Digital Methods for Long-Term River History, The Case of Yellow River in China. Em nome da Sociedade Brasileira de História da Ciência, eu agradeço ao Dr. Mostern pela disposição em participar do nosso seminário. Ao final, teremos espaço para perguntas, então anotem suas perguntas. A plateia local poderá fazê-las aqui, né, pessoalmente, enquanto quem nos acompanha pela internet pode fazê-las pelo chat do YouTube. Dr. Mostern is Associate Professor in the History Department at the University of Pittsburgh. Recently, in fact, she was promoted to full professor in the same department. Since her 2003 PhD from the University of California in Berkeley, she has studied Chinese history, developing long-term analysis of environmental issues, the space occupation, the relationships between humans and the landscape. Dr. Mostern has published 2 important books on the subject, Dividing the Realm in Order to Govern, the Spatial Organization of the Song State in the Harvard Yenching Institute Monograph Series in 2011. Last year, she published the book Use Trace, the Ecological and Imperial Words of the Yellow River by the Yale University Press. Dr. Mostern has made important contributions to use of digital technologies in dealing with environmental history, to rising talks in the historiography of science in Brazil. She closes today our national seminar with the conference Digital Methods for Long-Term River History, the Case of the Yellow River in China. On behalf of the Brazilian Society for the History of Science, I thank Dr. Mostern for his willingness to participate in our seminar. And at the end, we will have space for some questions. The local audience can do it here in person, while those who follow us on the internet can do it through the YouTube chat. Thank you, Ruth, for your talk, and the time is yours.
Great, excellent. Well, can everybody hear me, and can everybody see my screen? I hope. I think this is a history of science project in 2 ways, although history of science is not the usual community that I participate in. And it's really, my honor to be here, both because this is my first time speaking, even though it is remote in Brazil, and it is a rare opportunity for me to communicate with an audience of historians of science. And I think it's a history of science project in 2 ways. One is because it is an environmental history, and so I am always interested, maybe in 3 ways. It's an environmental history project, and so the topic of how humans interact with the natural world is a history of science topic. It's also a history of science topic because one of the things that I'm really interested in is how people over a period of thousands of years, literally thousands of years, understood their relationship with the natural world. And so it's an intellectual history of human environment interactions. And finally, because it's a topic in digital methods. And so these interdisciplinary questions about how we who are trained as historians can use methods that come from geography and information science and other fields of data visualization can understand our work is also a history of science question. And so these are the 3 ways in which I'm going to be introducing my recently published book to you as a history of science audience. So as I said, this is a book talk. I'm introducing my book called The Yellow River, A Natural and Unnatural History, which was published about a year ago by Yale University Press. And this is just an introduction to the press website for the book, if anyone is interested in taking a look and following along what the book says and what the press says about the book. But what I want to do now is to introduce you to my study area and to start to introduce you to my methods. So when I set out to write this book, what I was interested in doing was finding a topic that was about the long term of history, thousands of years of history all at once, and also that was about a really large spatial scale. And I started conceiving of this book as I was finishing my first book, which is about 300 years of Chinese political geography. And I was determined to keep working on geography and spatial methods because that's just what I'm most interested in exploring. But I wanted to find something that existed on the Earth's surface, a physically existing landscape, as opposed to the sort of imaginary landscape of political geography. And so I got interested in the Yellow River. And what I discovered as I started to read previous scholarship about the Yellow River is that it almost all focused on the region of the floodplain. And on the slide that you can see, the floodplain is the large green, light green area on the east side of the map. It's basically the lower course of the river where it enters the Pacific Ocean. And that almost all histories of the Yellow River ignored the upstream 2/3 or 3/4 of the flow of the river. And I would be really interested in talking during Q&A about how this might compare to Amazon history, which is a topic I do not know very much about. But what you can see on this map is that almost more than half of the course of the Yellow River passes through a region called the Les Plateaux. And this is a region that is characterized by a soil that is a depth of 30 or more meters, that is highly erodible, and that the history of what has happened on the floodplain is profoundly shaped by what has happened on the region of the Les Plateaux, which you can see here outlined in white on this map. But because the Les Plateaux is less densely populated, less wealthy, less urbanized, has been for thousands of years, I'll be talking about that over the course of this talk, and is also less prone to disasters of flooding, it therefore gets ignored in all these histories. And so I think in some ways this is a sort of classic history question, but specifically a really classic history of science kind of question, which is how does human activity, human social organization, and social structure literally shape what we as historians and what people in the past and the present are and are not able to see about the natural world. And so my proposition in this book and in my talk today is that the Les Plateaux has been essentially invisible in Yellow River history, and yet it is impossible to tell the history of what happened on the floodplain without really understanding what happened upstream on the Les Plateaux. This is another view of the same map and the same watershed. This one sort of dramatically dividing the watershed into its two regions, the Les Plateaux. What you see, I should say, to the west of the Les Plateaux is the Tibetan highlands from where the river originates. And I suppose in some ways I'm recapitulating the thing I'm complaining about here because I don't talk much about that upstream region. But you can see the Les Plateaux here to the west, the alluvial plain to the east. And what you see here with all of these different colored lines are different courses that the river has occupied at some point during history. And what you can see is that left to its own devices, that is, without human intervention to build canals and levees and reservoirs and drainage systems, the river naturally can move back and forth across the entirety of the alluvial plain that spans all of northeast China, occupying many river courses at once and moving between river courses and occupying the region of many wetlands and tributaries in between. This is not a version of the river that has existed for literally 2,500 years. Humans do not like rivers that act in this kind of way. And so the history of the alluvial plain is a history of the channelization of the river, the inability of people to keep the river effectively channelized, and also the way that erosion from the Less Plateau has shaped the inability of people to keep the river in one channel. And so I sometimes like to say that my book is actually, even though it's a book of river history, it's actually a history of the soil at least as much as it is a history of water. And this is this set of pictures I like to call my less selfie. And this is me holding a clump of this less soil that I've been referring to. And in the upper left picture, you can see that it packed together really well. It was actually used, this soil was used historically as a building material because it can be sort of pounded into a form that is as hard as concrete. But when it isn't pounded into shape like that, it can easily fall apart into just a fine dust, which is what you see in the other three pictures in this sequence. On the upper right side of this picture, of this slide, the image that you can see is less soil shown under a microscope. And what this reflects is the fact that this soil has grains that are very, very small, but also that are in multiple shapes, so that it has sort of gaps in between the grains of soil. This is why when the less soil is pounded down, it can become as hard as concrete. And it is also why when it is not pounded down, it just falls apart as dust like you see there. And from the point of view of environmental science, and I have this quote here from a couple of environmental scientists who have studied the history of erosion, this less soil is very resistant to erosion under vegetation cover, but readily erodible without it. So it's very, very permeable to water when it is covered with grass or trees or some kind of groundwater, but extremely prone to erosion without it. And as I talk also about my methodology, I've talked about being a historian, I've talked about doing the large scale and the long term, about using digital methods. The other thing that is sort of part of my orientation to history of science is that in the course of writing this book, I also read a lot of work by environmental scientists. And one of the things I would be really eager to explore in the Q&A, if anyone is interested, is what my experience was like as a historian without any environmental science training at all, picking up environmental science articles and just sort of learning to make sense of them. And for me, what that amounted to is really not being able to critically evaluate the methodologies of the articles, but finding it easy over time to sort of understand them as works of narrative, as works of change over time in ways that felt familiar to me as a historian. So that is also part of the interdisciplinary experience of having written this book. So the story of the Left Plateau is a story of increasing erosion because of the removal of ground cover. And what you can see in this image, if you read it sort of from right to left, This shows the rate of erosion approximately 12,000 years ago, around the beginning of the Holocene era, the end of the last ice age on the right-hand side of the axis, and moving to the present on the left-hand side of the axis, with the rate of erosion rising from approximately 0.2 centimeters of sediment deposition per year into the bed of the Yellow River up to 1.6 in the late imperial era, in the sort of recent centuries. Representing the erosion rate during the Pleistocene era, just as the ice ages were ending. Through the Holocene climatic optimum, this is the period when humans began farming in the Yellow River watershed, where the rate of erosion rose just a little bit. And indeed, as long ago as that, there were already signs of erosion in tributary riverbeds, even remodeling the shapes of valleys as a result of local erosion, but there was very little sign of erosion at the scale of the whole watershed. That's changed dramatically. As you can see, the rate of erosion basically doubles with the beginning of the Bronze Age, the Iron Age, the Neolithic era, right, rising to doubling from about 0.2 or 3 centimeters per year up to 4 or 5, and then up to 6 or 8. By the imperial era, the last 2,000 years or so, 2,500 years of Chinese history, the rate had tripled, quadrupled into this rate of approximately 1.6 centimeters per year. And so one way that you can track the intensity of land use is through these rising rates of erosion. Always there are low rainfall years. One of the things I kept in mind as I was working on this project, I was very interested and remain very interested in what difference climate and weather make. One of the things that I came to conclude is that climate change has not made very much of a difference in this history, at least not until recent decades, because the effect of human activity was so much more profound than the effect of climate. However, individual years' weather are really significant, and so even during these times when the most intensive rainfall can lead to very, very high rates of sediment deposition, there are also always low rainfall years, drought years, where not very much sediment moves down the riverbed. This is another view of the same data, measuring the amount of sedimentation differently, but looking at this same period of about 12,000 years, and with one period of erosion rising sort of steadily from about 10,000 years to about 1,000 years, and then a really rapid, kind of sudden change of state into a very different world of the rate of sedimentation. And this is actually the first image I saw as I was beginning to work on my book, and recognizing that some very dramatic thing happened about 1,000 years ago. And really, very much of my book arises from this question of what to do, right? How to explain and how to gather evidence that would allow me to explain what was it that happened about 1,000 years ago. And also in terms of, thinking about methodology, what this question of sort of when do slowly changing processes become derailed, change state very suddenly, and what to do with evidence of that kind of eventful and eventive disruption to slowly changing processes. That's another one of the frameworks that I bring to this project. So one of the things that I became interested in, because I saw that erosion was going to be such a significant part of my story, was to start to understand, and again, using reading from environmental science in order to understand what was happening with the erosion rate. And one of the authors whose work I learned a lot from is Hu Xiaobin, who defined this soil erosion in 3 phases. The first one around the rise of agriculture, another one during at the very beginning of the imperial era, that's from about 200 BCE to 0 CE during the period of the Western Han, the first long-lived imperial regime, and then the third one, which I just referenced, around 1,000 years ago. And all of this, as you can see in the quote here, according to the conclusions of Hu Xiaobin, is as a result of human-induced devastation of vegetation and anthropogenic disturbance. This is a human story. One of the other things I'll comment about methodology before I move on from this slide is that I've been emphasizing that I am a historian reading the work of environmental scientists, but it's a little more interesting and complicated than that, because this author himself is using, and you can see this, I don't know how big the screen is in the room you're sitting in, but you can see in his commentary under this screenshot I took from the article that he is using historical literature as well as pollen analysis. So that's, to me, a sort of an interesting picture of this story of circulation of knowledge back and forth between scientists and historians. So I, as a historian, reading the work of Hu Xiaobin, who's a scientist, who himself is reading the work of historians as well as doing pollen analysis in order to make his own case. One of the things that I love about studying Chinese history and why I feel so committed to doing long-term projects like this is because the temporal extent, the span of the historical documentary record goes so far back. It's really uniquely possible in Chinese history to be able to use methods like that. So I'm particularly interested, well, in the book, I'm interested in all 3 of these phases of intense increase in the rate of soil erosion, but really it's that one about 1,000 years ago that from my research I have determined is really the very most significant. And I want to talk a little bit about what happened. So this is, to me, the story of why studying the Less Plateau is so significant for understanding what happened on the floodplain. And the story of what happened on the Less Plateau about 1,000 years ago is a story of geopolitics, right? So I can't tell my river history without sort of zooming out and thinking about political history and the history of warfare. And the history is this. What you can see in the image on the left-hand side of this slide is in the south, a regime called the Song regime. In the north, in that sort of purple color, a regime called the Liao regime. And in the west, a regime called the Western Xia, the Xi Xia. And the Song was the physically smallest extent of any dynasty during a time that a single dynasty unified all of China. And they had a very, very hard time maintaining peace and security on their northern border. Very quickly, around the turn of the 11th century, the Song and the Liao established a treaty, and they said, here's our borderline, nobody crosses the border, we're done. That never happened between the Song and the Xi Xia. And so the 11th century, the whole 11th century, was a sort of a Cold War for 4 years, a hot war, but basically a Cold War between the Song and the Xi Xia, who never established a boundary with one another. And as you can see in the middle map here, the one that has the Xi Xia at the center, you see the Great Bend of the Yellow River on the eastern part of that map, right? This is the Yellow River that we've been looking at now for the last 20 minutes, that great bend through the Ordos, through the Lest Plateau, and the boundary, the sort of the hot war boundary struggles between Xixia and Song. You see the Song to the south, to the southern part of this map, right, was running right through the middle of the Lest Plateau. And so the way that the Song dealt with this was to establish a huge number of fortifications. You see here on the right-hand slide, there are stars which represent prefectures. These are large outposts of regional government. And you see these dots, which are individual fortifications. On the ground, this looks something like this. This is, I bring some archaeology into my project as well. And by the way, you can see here what that less soil looks like when it's pounded into walls and baked into bricks. That's the material that's used to make these forts. So in 1041, at the beginning of the first outbreak of war between Song and Xixia, there were about 34,000 horses and 155,600 people. This was also a multi-ethnic region. As this indicates, there were 32,000 imperial soldiers, 20 battalions, and so on. 4 years later, those 20 battalions had increased to 500, and those 32,000 troops had increased to 500,000. And in addition, 300,000 Xia cavalry and their horses had also entered the region. And so this is really, this story, I pretty much, even though this was 1,000 years ago, I'm able to pinpoint pretty much to this decade when the amount of human intensive land use destruction on the Lest Plateau really began. And you can see it here in the form of maps. Again, here on the bottom left is that reference map showing this whole study area. On the right-hand side, you can see 3 maps showing the history of fortification on the Lest Plateau, with the top one dating from the middle of the 8th century. And so you can see here that although there was a decent amount of human settlement, it was all oriented toward the southeast corner of the Lest Plateau. B is the middle of the 11th century. That's right before, sort of right in the middle of that troop buildup that I was talking about, which then amounted to what you see in slide number C at the end of the 11th century beginning. I think this is actually the beginning of the 12th century. I think 1111 is the date on that slide number C. And so you can see here that what this amounts to is a massive expansion of Chinese presence, towns, forts, people, horses, all of these settlements expected to provide for themselves agriculturally. So all of these associated with growing wheat and millet and sorghum, right, across the entirety of this fragile grasslands region. The image on the upper left that you see here is this very, very highly eroded landscape, right? Bare soil, deep gullies. This is located in a spot that 1,000 years earlier would have been right in the middle of that dense region of fortification, but which right now is barely able to sustain agriculture or a human presence. This is really that story of erosion kind of personified, sort of moving in from those dots on the timelines that I started with a few minutes ago, and these dots on a map into really imagining what this is like as a human landscape. And that star is just showing approximately where I took the picture that you see right above it. This continued onwards, even after the period about 1,000 years ago. If you hear about the Great Wall of China, that was not actually built until the 16th 15th, 16th century. However, it basically exactly follows the line of that series of stone fortifications that we were looking at on the last slide. And so beginning 1,000 years ago, but continuing onward, first with the continuation of the military presence during the Ming Dynasty, during the Great Wall era. That was also basically an era of colonialism, of ethnic removal, of turning the Lest Plateau south of the wall into Chinese agrarian enclosed space. And then moving onward from there, there are also economic stories throughout the last 1,000 years. The rise of a timber industry about 1,000 years ago, a commercial timber industry in the monetized economy of the Song, forestry during the last 300 years, farming of New World crops, potatoes and corn during the last 400 years ago. All of those put additional erosion pressure on this region, although there were also reasons having to do with politics, having to do with weather, why this was not a sort of a simple story, right? Where historical stories never proceed simply in a single line. I want to talk here a little bit about method, which I know is one of the things that I have promised here. So where did all of this data come from? So I am interested, and I'm about to sort of pivot to talking about the floodplain also. So all of those points on the map that we were just looking at, showing where all of those fortifications were built, come from an atlas called the Historical Atlas of China, the Zhongguo Lishu Dituji, and which has sort of about several dozen kind of points during time, during all of the times from which we have historical censuses that list all of the populations, even for villages and towns. And so that's what I was mapping in the slides that I was just showing you. And then for the units above county rank and above, the sort of the larger size of cities and administrative centers come from a project called the China Historical GIS. I'm about to start talking also about the floodplain data, which is the other half of my project. And that comes from 62 lists and tables that are spread across 10 Chinese publications that have names like the Yellow River Annals, the Huanghe Nianbiao. For all of those, I georeferenced the locations of the events mentioned in them. I coded them by event type, and I determined a list of 3,754 events. I was inspired here, and this is again one of the things that I read early in working on this project that really inspired all of my work, was the work of an author by the name of Shen Yi, who's the author of the Yellow River Annals. He was a civil engineer, director of the Yellow River Water Conservancy, went on to have an illustrious political career, ultimately in Taiwan after the Chinese Revolution. And he was the first person to compile all of those historical events and of Yellow River history, that is, taking them from primary sources, linking back to the primary sources, but putting them in the form of tables that can be referenced and analyzed, and very inspirational to what I'm doing. And again, I don't know how clearly you can see this on whatever screen you're looking at, but what you can see in the sort of the bottom middle of the slide that you're looking at is one screenshot from the Jupyter Notebook environment that my research associate and I built in order to analyze this data. One thing that I should also say, as we're talking methodologically about this work, is that it was highly collaborative for me. I myself have only sort of introductory levels of database skills and GIS skills and data visualization skills, but I was grateful and honored over the years to work with a series of undergraduate and graduate students who helped me to digitize and encode the data that I'm referencing here, and with one very talented database designer and cartographer who is the person who developed all of the maps that we have looked at up until now. And so this Jupyter Notebook environment that I have screenshotted here in the bottom middle of this slide is the environment that Ryan Horn, my database author, and I use to collaborate. And it is, I can't see it myself here. Right, this is a list of some of the floods that occurred about a little over 2,000 years ago on the floodplain. And it's from this kind of data that I built my argument about the history of flooding. And this I definitely do not anticipate that you will read. If anyone loves SQL, it is here for you to look at. But this is the kind of query that my collaborator Ryan developed in order to answer the questions that I was trying to ask. So this is how much of a query it takes to combine the events, places, the joins of places to events, the types of events, the floodplain geography, buffer regions, in order to ask how many floods were there, right? How many places were affected by some event? How many places were affected by a whole category of some type of event between a certain number of years? And so we developed, or I asked the questions that allowed Ryan to develop 500 such queries in order to answer, just iteratively drill down into my data and see what kinds of patterns I could derive from it. And also absolutely reaches really, you can see the complexity of these queries. This is really kind of at the edge of what is possible to do with a relational database. This is what some of the raw data looks like. I've actually been working with one of my graduate students this summer and with Ryan in order to do the final work of cleaning the data to the point that not only can I use it for my own work, but that I can also release it publicly in a way, in a way that is clean enough and well enough organized that other people can use it, hopefully without writing queries that are quite as complex as the one I showed on the last slide. And what this shows is a piece of the gazetteer that we're developing. Gazetteer being a list, being a type of index organized around named places. And so these are some of the place names that appear in my data set. And always, one thing I'll say methodologically, and maybe sort of by way of advice to anyone who hasn't yet done a project like this, but is contemplating it, is that I worked on this project. It took almost 10 years to finish this book. And over the course of many of those 10 years, I knew that I was interested in doing something with data. I was collecting data. I did not know what final form the database would take because I was not clear enough in my own questions and because I had not identified the perfect collaborator. But what I ensured is that every piece of data collection that I did, I was maintaining very, very clear ID systems that were consistent and clean, and that every new time that I collated the data, that I took some of my existing data and put it together, that I was always maintaining my old ID numbers and linking them to my new ID numbers. And that's what allowed me to feel a high level of confidence in the quality of my data, even as I worked on this project very slowly and with a lot of different collaborators and without always knowing exactly where I was trying to go with it. And so one of the things that you can see if your screen is large enough is a whole set of old ID numbers as well as new ID numbers, and here also beginning to work out a thesaurus of feature types. So this is some of what my data looks like all the way behind the scenes, looking at individual data tables. This is another example of what some of my data looks like behind the scenes. And the reason I like to show this particular view of it is that this also includes what you can see there in column L and column K is all of the primary source quotations from which the information about historical events is derived. And so even when I'm just showing timelines and maps and very highly processed data, it's really important to me as a historian always to make sure that that is possible for me and possible for anyone else referencing my work to be able to sort of drill down and go back all the way to some quotation from some primary source, right, where a named individual is making some attestation about something that happened on one particular date. And so what we're looking at here is the year 1194, so it's right in the middle of that what happened about 1,000 years ago period that I always focus on. And it's a variety. Most of these quotations come from a source called the Jinshi, the history of the Jin dynasty, which itself sort of is a collation of government reports by local officials on the spot. So this is a series of local officials in 1194 saying, this is where the river is flooding right here, right now. This is how many towns are affected. This is how many people are affected, right? And because this is basically the work of local government, also saying things like, you can't expect these people to pay their taxes this year, right? Their land is flooded. And so it's always possible for every single one of the events in my database to go back to information like this. And this is just an example of some of my upstream data, which, like I said, is much more simple because I myself did not go back to the primary source records. I went back instead to this project called the Historical Atlas of China. So these are just point locations from the Historical Atlas of China, but always, as you can see here, in indicating in the page number column, as you can see, that all of these are saying what volume, what page. There, I'm absolutely following rules of historical citation throughout this project. So I want to turn now, and I know my time is getting a little short. I have maybe 15 minutes. I want to talk about I talked already about method. I talked about the big picture of erosion over thousands of years. And I talked a little bit about the political history of what happened on the Less Plateau. What I want to turn to now is the floodplain history, right? What I said at the beginning of my talk is often told as the only part of the history of the Yellow River. Absolutely is a part of my story as well, and a part of what all that data analysis I was just showing you is about, but trying to link together the erosion history and the history of the flooding. What you can see on this slide is a couple of images. One of them is from the 18th century, and it's from a manual explaining how to manage the flooding or the potential for flooding, the sediment deposit of the Yellow River on the floodplain. You can see the Yellow River conveniently colored yellow there, and its confluence with other smaller water courses and canals that are not full of sediment. And basically the problem that is being described there is how to make sure that that Yellow River sediment does not flow into other critical water courses. On the right, you see a version of exactly the same project. This is the Xiaolandi Dam. This picture was taken maybe 5 years ago or so, and showing exactly the same problem, how to remove the sediment-laden water of the Yellow River from the dam mechanisms so that the turbines can continue to run. The muddy water can get sluiced out and the clear water can move through the dam turbines. So this is the problem that people have been struggling with on the Yellow River floodplain literally for thousands of years. The overall history of flooding looks something like this. If you take all of those data points that I was just showing you, the sort of behind the scenes look at, and record them all on a map, let's map all the flood points, you get something like this. And especially what you can see here, if you recollect the maps that I showed you earlier in my talk, is that the amount of flooding on the Less Plateau is very, very small. But as soon as the river disgorges onto its floodplain, and you can pretty much see exactly where that happens, immediately it is a region of very, very intense flooding. You can even see here the various different water courses that the Yellow River has occupied. Most of the flooding during the imperial era, as you can see, is associated with this southern water course, which is not the current water course of the Yellow River. And so you can see that the places that people were writing about, scrutinizing for flooding, are the places where the water was at any given time. This is a city called Kaifeng. It was actually the capital of China during the Song Dynasty, this period about 1,000 years ago that I keep circling around. It was a terrible, terrible place to build an imperial capital. Terrible idea to build it there for exactly the reason that you can see. And indeed, the reason why it was used as an imperial capital is because it was so flat and so low-lying, and therefore it was possible to build transportation canals that linked it to the wealthy and populous lands of South China, and to be able to transport people, transport food, bring in clean water. It was a great idea for those reasons, but a terrible, terrible reason from the point of view of flood history. And the image that you can see here on the top left side of the slide is a current extraordinary archaeological site at the location of the historical city wall of Kaifeng. And it is going down like tens of meters, I think something like 50 meters, in order to excavate all of the floods that occurred at this site. It's this work of geoarchaeology, basically, to look at the sizes of sediment, the organic material embedded in the sediment, and basically count up all of the floods that occurred at this site, and to be able to understand the magnitude of each flood from the size and type of sediment that it deposited. And so this is, again, a sort of an abstraction of what it means to live in a place that is prone to the kind of flooding that we're talking about here. This was, like I said, this was an imperial capital in the 11th century. It was perhaps the largest and richest city in the entire world at the time, larger than Baghdad, right, which would have been the only competitor probably. And yet now is a sort of a kind of impoverished third-tier city in China. And that is basically because it became impossible to maintain as a result of all of the flooding. And then this is my abstraction from my data showing all of the floods around. I think this is within like a 50-kilometer buffer of the city of Kaifeng in my data set, and the way that all of the different multiple courses of the Yellow River have passed through and around this former global metropolis. So one of the ways, and this is also the same data, this is all of the historical floods that occurred within this 50-kilometer buffer of Kaifeng. And the other thing that this shows is the history of moisture. So one of the other data sources that I worked with was called Monsoon Asia Drought Atlas. And so one of the questions that I was interested in asking is how the rate of flooding corresponded to the intensity of rainfall. And it sort of does. I'll talk more about that in a few minutes. But what I want to focus on here is, once again, circling back to this question of what happened about 1,000 years ago. And so you can see that prior to the turn of the 11th century, around the beginning of the 1000s, there are almost no floods recorded. And then after that, the rate of flooding is very high. There's an interesting anomaly here during what you can see marked as the Southern Song and Jin era. That is 100% just a data anomaly, right? One of the things that I've been mindful about throughout this project is that by collating historical records, I'm relying a lot on the quality of those historical records. And there's one period, you can see it exactly corresponds with the beginning and end of one particular regime that just was not interested in recording flood information. So that's a very, very interesting thing to note also. And we can, I have a lot to say about that, and we can talk about that during Q&A if anyone is interested. So basically breaking down into several eras, right? A first era of very little flooding, a second era of the beginning, the very sudden onset of high flooding that continues on, becomes even more extensive following that data anomaly. And then interestingly, in spite of the fact that, as we've seen, the amount of sedimentation continues to rise throughout the later imperial era, there was less flooding. And what this means, as I discovered as I continued working on this project, is that basically what this refers to is a period starting in the 1500s, going from basically the 1500s through the 1800s, when in fact people did a really good job of controlling flooding in spite of the fact that the amount of sediment was going up. So essentially, one way of thinking about these numbers is, first, an era where floods were almost non-existent because sediment deposit was low. Second, an era of high flooding because sediment was high, but the rate of sediment deposit was not being managed. And then a third era where sediment deposit was even higher, but where people had learned the skill for how to build levees and other kinds of waterworks, and where the government was determined to spend as much money as they needed to in order to keep floods as minimal as possible. This is another view of this is not Kaifeng anymore. This is all the data in my event Lower River event database. There's a lot packed into here, and I don't want to talk about all of it. We can go through it more in Q&A, but basically what I want to indicate here, this goes back to the very beginning of my data. That's in 750 BCE, that there are almost no disasters or acts of river management recorded until the late 800s. There's a long, long, uneventful part of Yellow River history that goes from very earliest times until the 800s. And then there is this later period when there's a huge amount of recording, both of floods and also acts of management of the river system. Toward the end of the era, again, we see here what this represents, and I can explain. Well, this is a what you see in this black line is the percentage of disasters that were breaches of levees. And so this basically represents a period of time in the 1700s, late 1600s through mid 1800s, basically, when the government put a huge amount of skill and science and effort and money into keeping levees from breaching as much as possible. And that's another really interesting piece of the history of what we of long-term Yellow River history. This is another version of the same data, For a while, again, this is the dotted line is moisture levels. The white line is disasters. The black line is river management. And what you can see is that until the 17th century, there's always more disasters than there are acts of river management, and that the management and disaster lines track to one another. That is, what that's showing is that managing the river was responsive to the flooding of the river. You can see that that changes very dramatically. And again, this is tied to the beginning of a new regime. You see here the new Qing regime, which comes into power in 1644, totally changed the world of river policy and did a huge amount of effort. You see these black lines peak and then peak again, rise far, far above the level of the white line. So again, these black lines show the history of the management of the river. The white line shows the history of disasters on the river. And so right here, with this kind of large-scale data analysis, you can tell a history of long-term policy change, a way that would be much more difficult if you were doing a sort of traditional analysis of historical sources. And then you could see exactly where this ends in the middle of the 19th century. You can also see where and when it is that moisture levels start and stop having a relationship to river history. So up until the late 900s, even when there were years of very heavy rainfall, there were still few river disasters. And then for a while, for the centuries at the beginning of the disaster era, the disasters tracked to rainfall. You can see the peaks and valleys in disasters are tracking exactly to the peaks and valleys in rainfall. But then you can also see, actually, no, I don't have the next slide, right? But by that next year, I'll go back to this slide, right? That ends, that comes to an end in the period after the 17th century, when even times of high rainfall were not times of high disaster. And so this is showing the relationship between human-induced sedimentation, river management, and climate history through this sort of data analysis method that I've used in my project. I know I'm coming to the end of my time, and this is also coming to the end of my slides. I think I'll skip this. This is zooming into one specific region. I think what I want to do here is just very quickly show how very, very much river management was done. I mean, to build levees and canals and dams and sluice gates and other kinds of waterworks in the most critical parts of the floodplain. And another version of the same data that you've seen before about this interesting story of what happened in the 17th and 18th century. I want to do a couple of things on this slide. One is just to show, again, that same region. This is near a lake called Hongze Lake. I would be happy to talk about this more in Q&A, but this was really the most critical location on the late imperial Chinese floodplain of the Yellow River, because it was the confluence between the Yellow River and a canal called the Grand Canal, which linked North and South China together and really provided the lifeline for the transport of rice from the wealthy and fertile south to the north, where the capital was located in Beijing. And that is really, this is sort of the punchline in a way to why did the late imperial regime put so much effort and so much money and so much science into managing the Yellow River. The answer was their concern with the Grand Canal, and we can talk more about that. The image on the upper right is actually taken right here. I was lucky enough to take a tour of this region around Homza Lake and found exactly this kind of retaining wall, which directed floodwater into this series of smaller lakes and onto farmland rather than into the confluence between the Yellow River and the Grand Canal. One of the things I want to say and show with all of that is this quote, one of my favorite quotes from my book, from a American water engineer in the 1940s, that floods are acts of God, but flood losses are largely acts of man. And this sluice gate, this retaining wall, stone levee that you can see here in this image, shows exactly what that means. That is, the fact that there was high water in the Yellow River is because of an amount of rainfall. And even the fact that there is less soil, there's sediment in that water, that is partially a result of human activity, but it's also just simply systemically part of the territory that the river flowed through. But the decision to take that high water and use it to flood certain vulnerable people's fields rather than impinging upon this important transportation route, this lifeline of imperial power, that was a human decision. That is a thing that a regime decided to do in order to flood vulnerable people rather than putting the regime at risk. And that's where I want to end up here. I think this is my almost last slide, which is that all of these floods are human disasters. It's easy to forget. It's easy for me to forget when I'm sort of out in my timelines and my thousands of years, that all of these events were things that displaced people and residents. People lost their homes and their lives. People labored under very, very dangerous, sometimes fatal conditions in order to mitigate the results of the flood. And so I want to leave us coming down to human scale once again. And with that, I want to thank you all for your time and your patience. I want to thank all of my collaborators and assistants, Ryan Horn, my database collaborator, and several outstanding students, Kai-Chi Hua, Shen Feng, Xiaobai Xiong, a new student I have not added to this slide yet, Sharon Zhang. This was such a collaborative project, and I want to end by honoring their time and expertise as well. So thank you very much. Let me unshare my screen, and I would be happy to take some time for Q&A.
Okay, thank you, Ruth. Wonderful work. We'll have some time to do a little questions. Well.
Oi?
Okay. Oh, for me, it's very astonishing the lot of work, interdisciplinary work you did in order to obtain your data. And you said about the historians and scientists' interactions. Was I trying to understand one more is firstly, how did you obtain the data on the flood? Because you have data from 1,000 years, a lot of time. It's your archaeological information, or in China they have collect this kind of data in, for example, the Yellow River annals. How do you organize this kind of information in order to construct a stable analysis of long duration or long duration, as you said. Can you speak a little bit more on this, please?
Yeah. So one of the things, I was giving a different talk yesterday, and someone asked me the question about how I sort of work with Chinese collaborators. And one of the things that I always really like to do in my work is to kind of sort of showcase and uplift Chinese style methodologies in my work as an American historian. And one thing that historians of China in China really like to do, that historians of China outside China and maybe Japan did not do as much, is to make really learned, comprehensive, published lists of information in some category. And they don't typically digitize it. They don't typically make it available, at least in a database format or to use for maps and data visualization, but they make these extraordinary print publications that are just these lists of data, of essentially what I think of as being data. And so I think I mentioned on one of my slides that I found, was able to, just through bibliographical research, identify sources like the Yellow River Annals. There are other sources with names like, history of meteorological disasters or history of agricultural disasters, this kind of thing. And I was able to identify 10 books and a total of 65, I think, data tables in those 10 books that are just lists of events with dates, locations, and quotations from primary sources. And so that's what enabled me to create this comprehensive list of historical events. Without myself, it would have been impossible. It would have not been a project that one person or even a small team of people could, complete within a reasonable amount of time, to go back to every single one of the dozens and dozens of relevant primary sources in order to find the original records of all of these events. So what made my project possible is that teams of Chinese scholars had already done that work of identifying the historical events, so that all I had to do, it was years of work, right, was to sort of digitize those data tables, collate them together, sort of split and merge events, put everything in a standardized format, but not to actually have to go back to the primary sources myself one by one.
Okay, thank you, Ruth. We have another question, please.
Thank you very much for the talk. My name is Carla. I don't know if you can see me. I'm sure. I don't think so. Yeah. So I am still trying to formulate my question, but let's see if I can do it. I am also not an environmental scientist. I don't know much about erosion and floods, but you mentioned that the flood region is often more studied than the plateau region is often historically forgotten. But then I want to ask about the connection between your history on the plateau and the floods, because you said that you make a really strong connection between the sedimentation and the erosion to the history of the floods. And then from the from the 10,000 years, in the last 10,000 years, no, not 10,000, in the last 1,000 years, you said that the floods were more caused by canal modification, right?
Mm-hmm.
Then the history of the plateau area does not influence on this flood in the recent years. 1,000 years, recent years. What is, because if the modification is done in the flood area, you don't have an influence on what happened in the plateau to the floods. Is it clear? I mean, I'm still trying to.
Yeah, I think let me answer and then you can tell me if this is what you meant.
Okay.
So prior to 1,000 years ago, there was not, the rate of sediment deposit was relatively low. The rate of flooding was also relatively low, and the rate at which people were building flood control structures on the floodplain was also relatively low. It was just what I call the uneventful era of river history. Then, from about 1,000 years ago to about 500 years ago, the rate of sediment deposit and erosion were high. The rate of flooding was high, but the rate at which people were building flood control structures on the floodplain was still relatively low, higher than it had been before, but still relatively low. And then starting about 500, 400 years ago, the change was that even though there was more erosion, more sedimentation, there was not more flooding. It was still high, but not as high as it had been before. And that is because people were building flood control structures that were relatively effective. Does that make sense? Is that what you were asking?
Yes, but how does it connect with the history of the plateau? Because you started
Right. So the history, yeah, okay. So the history of the plateau is that the history of the plateau is what were people doing that caused erosion to rise and rise and rise, right? So the plateau history is basically, to simplify matters somewhat, erosion gets higher and higher and higher as humans are being more and more disruptive to ground cover. That's the plateau story. The floodplain story is the somewhat more interesting and complicated story, which is you would expect that because the rate of deposit of sediment was getting higher and higher, so was the rate of flooding. And the interesting thing is that that was true for centuries, but then it ceased to be true at a certain point. And, one thing that I, didn't include is some of the, of course, I do read primary sources sometimes. That's, of course, part of my work as a historian. And, one of the things that happens in the last few hundred years, that era of intensive and relatively successful management, is that you get people saying things like, boy, there is so much sediment in this river. There's so much mud. It's really getting difficult, but here's what we can do. So they were aware, they knew where the sediment was coming from, and they knew that matters were getting worse and worse. And so the policy decisions that they were making were happening in the context of their knowledge of what was happening. One thing I didn't say in my talk that I often do, and that I should have probably, is that, I often, as I was working on this project, thought about it in terms of contemporary sort of discourse about global warming, right? Where also every scientist is very clear about what's happening. And every scientist is very clear about what it would take to stop the temperature from rising. And yet it is essentially politically impossible to do that, right? And the same thing is true in Imperial China, where many people were absolutely aware of where the sediment in the Yellow River was coming from, but it was impossible from a policy point of view to say, okay, we're just going to abandon settlement on this large expanse of the Less Plateau. Does that answer your question?
Yes, perfectly.
Mhm.
Thank you very much.
Any another question? I don't see what happened at YouTube or anyone. Well, my question for you, Ruth, again is, yes, your work has connections with the occupation, the settlements of China of this region, and probably what you're saying, I suppose, for people there is, see, the occupation, the settlements are causing all these environmental problems. What do you have to say about this perspective of public historian? I mean, what the Chinese people or your colleagues in China say about your work, the reception of your discoveries, etc.
Yeah. It's so one of the way in which I was most writing with a Chinese public in mind is that the sort of Chinese stereotype about the Yellow River is that it's always been prone to disaster and that it's always been difficult to manage, right? One of the nicknames for the Yellow River is China's sorrow in China. And one of the things that I think in some ways is just the work of historicization, but also is intended to be kind of hopeful, is that the era in which the river was intensively managed was only a period of about 300 years. And what that meant, right? What life on the floodplain looked like prior to that 17th through 19th century period of intensive management, which also meant fewer disasters, but more disastrous disasters when they did occur because the population was so high and because people lived so close to the river. Prior to that, when people expected floods to happen frequently, but when each of those floods was smaller, is that there was a more sort of sustainable relationship between people and the river. People didn't live as close to the river. People didn't build settlements that were as permanent. There wasn't as much investment of big land ownership capital. And it was a different kind of world, right? With more floods, but smaller floods, people, being less anchored to specific pieces of property, less income inequality, a more environmentally healthy and sustainable landscape. And so, sort of in the background of my work, I'm just pointing toward that as one of the options that wasn't taken during the era of high modernity, not taken in China and not really taken anywhere in the world during the era of high modernity, right? But that there was another medieval and early modern option that was possible. So that's been an interesting conclusion to share with colleagues in China. This work has gotten good reception where I've shared it. There's a huge kind of industry, entire centers and institutes and government agencies devoted to studying the Yellow River and, of course, the contemporary river, but also its history. And I think part of the response that I get is just people's kind of interest and gratitude to know that people outside of China are paying attention to all of that, but also looking at my methods of data analysis and data visualization, which are new to them, even though this is all content that they've been working with.
Okay. I think we can finish. We can again thank you, Ruth, for your talk, and we'll close the seminar. Okay. Thank you, Ruth.
Okay, thank you so much. Great. Bye-bye.
Bye-bye.
Bye-bye. Bom, gente, esse é o final.
Não, ainda tem
Não.
assembleia.
Isso, a assembleia é parte do seminário, então eu não posso dizer que está terminado.
Estamos caminhando para o encerramento.
A gente está caminhando para o encerramento, a gente faz uma pausa agora para a hora do almoço, que é só agora, meio-dia e 19, a gente volta aqui às 2 em ponto para fazer a assembleia, tá bom? Muito obrigado, a gente se vê mais tarde.
Daqui a pouco não vai ter ninguém na assembleia. A votação para 68 pessoas.